Hello and welcome to the channel. At last, good to see a real paper addressing a real world problem. And the good thing is that the language is quite straightforward and you can easily tell what this abstract is trying to say. This paper is describing a research that proposes a new method for improving large language models without relying on human supervision. The key points of this paper are revolving around the self-improving large language models. Existing method for self-improving LLMs focus on improving models' responses but not judgmental capabilities, which leads to rapid saturation during training. And this paper introduces a solution which is called as meta rewarding step, where the model evaluates its own judgments and uses that feedback to refine its judgment skills. This unsupervised approach improves the model's ability to judge and follow instructions, as demonstrated by significant win rate improvements on two evaluation benchmarks, Alpaca Eval 2 and Arena Hard. So paper looks quite good because it suggests that self-improving models without human supervision are possible, paving the way for more advanced and autonomous AI systems. They also have given quite a good examples which are easy to understand. For example, this is the diagram which shows you the process for meta rewarding. In this method, they have assumed a setup where they only have an initial seed model, an instruction tuned LLM, and no further human supervised training data. The idea is to generate training data from model itself through an iterative self-play process. In this process, the model assumes three main roles. As an actor, it generates responses to given prompts. As a judge, it evaluates and scores its own responses. And as a meta judge, it compares the quality of its own judgments. While training the actors to generate better responses to user queries is the final objective, this training's efficacy relies on accuracy of the judge. As the judge's accuracy increases, it will provide higher quality feedback for training the actor, ultimately leading to a better actor. Therefore, the objective of meta rewarding is to improve the model's capability both as actor and judge during training. The role of meta judge is to provide feedback necessary for training the judge. This method is an iterative training scheme that starts from the given seed LLM, which assumes all three roles. An iteration starts with the actor generating multiple response variations for each prompt. This is followed by judge evaluating each response using an LLM as a judge prompt and generating a judgment that contains a score. This score then allows us to build preference pairs of responses for training the actor. For training the judge, they have picked a single response and let the meta judge compare two of its judgment variations generated by the judge to determine which one is better using an LLM as a meta judge prompt, as you can see in this diagram. This step enables them to create preference pairs for judgments that can be used for training the judge. And once they have the preference data both for the actor and the judge, they apply preference optimization on the dataset with direct preference optimization or DPO. Also, while other RLHF or reinforcement learning with human feedback methods can be employed, they have chosen to use DPO because of its simplicity and stability. After the training, they have ended up with an improved model that will be then used for the next iteration, both for generating training data and as an initial model for the optimization. There is a lot of other good stuff happening within the model which you can read through and then see what exactly it entails. But I really like the way they have described it. This new mechanism for improving the judging skills of model by using a meta judge that assigns meta rewards to select chosen and rejected judgments for preference optimization, because it addresses a major limitation of self rewarding framework, specifically the lack of training the judge. Also, to make it work, they have additionally introduced a new length control technique to mitigate the issue of length explosion when training with AI feedback. So that's it. I will drop the link to it in video's description. Very nice read. I would highly suggest that you read it, and I'm sure you'll be able to understand it. Most of it, I'm sure. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network as it helps a lot. Thanks for watching.